So, uh, hello everyone. Uh, so first I will give my introduction. So, uh, I am Kritika Kadwasra from IEOR department of IIT Bombay, and I am currently in my third year of PhD. And today we are going to discuss few questions regarding the course Introduction to Probability Theory and Statistics, which is taken by Professor Dharmaraj on NPTEL. So I'm just waiting for everyone to join. So, how many of you have gone through the lectures from week 1? So, the basic question, am I audible? So, okay, huh. Okay. Okay. So, what is this jam file? I'm not able to access this. Who is this Zafir Beg? Okay. So, as I have seen, few people have attended the lectures, and this is a first week is about basics of probability, and so we can start with the assignment questions. So the which are based on basic probability theory, and let me know if you people have some doubt on those questions. So should I start? Let me know. Okay, so I will start questions one by one. So are you guys able to see this font? Okay, I didn't present with this screen. Right? Yeah. So are you able to see this? Okay. So first question is, suppose that 6 good eggs and 2 rotten eggs have been mixed up, and to find the eggs we test them one by one and at random without replacement. So here without replacement is an important aspect, that from those 8 eggs, total 8 eggs, when we remove one egg, we are not like after checking the egg, we are removing that egg from that uh, particular group of eggs. Okay, so it's without replacement. So now they are asking, what is the probability that both the root and eggs are find in the first two tests? Okay. So so can you guys try this for like for 1 minute, and if not, then I will anyway will solve it. But I want you all to try this at first, and let me know your answers in the solution box, in the chat box. No, 1 by 8, 1 by 4 is not correct. Okay, so I will solve this one. So uh, we have total. Sorry. So we have total. Okay, 8x, 6 good and 2 rotten. Right. So if so there are total 8 and 2 of them are rotten. If we when we remove first rotten egg, probability of that will be 2 by 8, right? Because there are 2 rotten eggs and 8 total eggs. So probability that we will get the rotten egg when we pick the first egg, it will be 2 by 8 because there are total 8 rotten and 8 total eggs. Then after removing this first one, now this rotten egg will be 1 remaining, and there will be total 7 eggs. So now the probability that the second one is also rotten will be 1 by 7. So this is the answer. So did you guys did you all understand this concept? The Khushi is right. So this thumbs up kind of thing will be okay if you can all raise your hand, or like any way of showing that you all understood and you all are with me. Okay. Okay. Then why did you write the point? So because in the question was like what is the probability that the both the roten eggs are uh, that the both the first two eggs that we you know mm, sorry extracted from that group of eggs will be roten. So we multiplied them because both those events are mutually exclusive. They are independent events. The first event is not dependent on the second event, and second event is not dependent on the first event. And if we want to find the uh, uh, probability of both the events, and if they are independent, then probability will be PA into PB. So, so wait a minute. So, PA is the probability that first egg is rotten. PB is the probability. So, PB is probability that second egg should be rotten. So, at the second event, the total number of rotten eggs was 1 and the total number of eggs were 7. So, now these two events, and we want to find that these both events will occur simultaneously. and both these events are independent of each other. That's why if we want, that's why we multiplied it like PA into PB. So I hope, okay. Yeah. So now moving to the second question. So this is the question now. A man and his wife appear in an interview for two vacancies in same post. So there are total two vacancies, and probability that husband got selected in that job is 1 by 7, and for the wife's selection the probability is 1 by 5. So now what is the probability that only one of them is selected? Okay, so try it on your own and let me know the answer in the chat box. I will give you 1 minute of time, and then I will show you. So this Sridip and Avinash are close but not exactly right. And Zafir 1 by 12 is not correct. So let's try. So now the probability that the husband will get the job is 1 by 7, and probability that wife will get the job is 1 by 5. Now these both events are again independent of each other. So now we want to answer the question, what is the probability that only one of them will get selected? So if the husband, what should be the scenario? That first scenario will be, first is that husband gets the job, and second will be wife will get the job. So if only one of them gets job and if husband will get the job, then probability will be 1/7. But it should come with that the wife will not get the job. So probability that wife will get the job is 1/5. So probability that wife will not get the job will be 4/5. Okay, so this is the probability that only husband will get the job. Then we will add the another scenario where only wife will get the job. So probability that wife will get the job is 1/5, and it will come along with that husband will not get the job, which is 6/7. So this comes out as 10/35. Yeah. So a lot of you uh, gave the correct answer. Answer it is 10/35. So anybody has doubt in this question? Okay, so we will move to the next question. So please try this one on your own, and then I will show you. So I hope you all saw the question. So it is saying that in oh yes, Astik. So so what is the question, Astik Sharma? Okay. Okay. So there are total uh, 8 red balls, 7 blue balls, and 6 green balls, right? And we want to find that the probability that neither of them, if the one ball is picked, neither of them will be red or and not the green. Okay. So it means that the ball should be of blue color. So total number of blue color balls is 7 and total number of balls is 21. So it is 1 by 3. So the basic definition of probability is that probability of any event is the chances associated with that event upon chances of all the events. Okay, here the total number of balls are 21 and we want to draw a ball which is neither red or green. So which means that the ball should be of blue color. So there are total 7 blue color balls. So it means that the total possible outcome that are in favor of this probability of in favor of this drawing a ball of blue color is 7 and total number of events of drawing a ball of any color is 21. So that's why this is the probability 7 by 21, which is 1 by 3. Yeah, so this dead shot has given the right answer. Okay, so we will move to the next. Okay, so we will move to the next question. So please try to solve this question. So anybody else? Ah, yeah, you all are correct. So it is point 4. Okay, so let's see. So here the students who so the students who offered English course is 0.3. Students who offered Hindi course is 0.2 and the students who offered either English or Hindi, so I can say intersection of these two events in the students with course English course and students with Hindi course, that is 0.1. So here I can consider event 1 as um, student with English course and event 2 will be students with Hindi course. Okay, so probability of the students who offered English courses 30, it is 30%, so 0.3, and the probability that the students are offered Hindi course is 0.2, and probability that the student is offered both English and Hindi is 0.1. And now the question asking is, if we select a person randomly, then what is the probability that he is offered either Hindi or English? So basically the question is of union of these two events. So we need to find a student which has either either English course or Hindi. So we want to find probability of E union H, like event union of these two events. The formula for this is sum of the individual probability and subtract the probability of intersection of both these events. Okay. So on solving this, it is 0.3, this is 0.2 minus 0.1, so it will be 0.4. So basically, if this is event E, this is event H, this is event E intersection H. But here we need to find out probability of E union H, which is this whole region, this region, and this whole region. Okay. So now when we are adding this probability of E, probability of H, and then we need to subtract this part, because this part is added twice. Okay. So that's why if we are calculating this E union H, we need to remove this part, because in PE and PH this part is counted as twice. That's why we remove this intersection. Okay. To find this E union H. So anybody has any doubt in this question? So I'm moving to the next question. So, in this, you are considering an event of tossing a coin, and outcome of each event is observed until 3 consecutive heads are observed or 5 outcomes are observed. Then you need to find the sample space of this experiment. Okay, so is anybody has doubt regarding what is a sample and what is sample space, what is experiment? So I can assume that everybody knows what is the sample space of an experiment. Okay. So now we want to observe the outcome of a coin. Like we will keep tossing the coin, and we will observe the event until we get 3 consecutive heads, or we can get 5 we get total 5 outcomes. Okay, now we want to find the sample space of this experiment. So we can go from each of these 4 options. So first element of the sample space is heads, heads, heads. So this is this can be counted as the sample space because it has 3 heads. So we can stop the experiment after 3 heads. Now the second is 3 heads and 1 tail. So this is not the correct sample space, because uh, we are observing the outcome until the until three consecutive heads are occurred. So after three heads are occurred, we will stop doing our experiment. So this is not correct. Okay, this heads and tails, because after three heads we will stop our experiment. Okay, so this option is wrong. Then moving to the next section. So it is three heads, that is correct. Then one tail and three heads, this is also correct. Then this is also correct because this has three consecutive heads and it also has total five outcomes. This one is also correct. Then this one is also correct because it has total five outcomes. Okay. This event also has total five outcomes, and none of the heads it do not have three consecutive heads. Similarly, this is also correct, this is correct, this is correct, and this is correct. Now moving to the next option, we see that these all are same, but here we see that there are three consecutive heads, and then we didn't stop here. We again toss the coin and the outcome is tails. So this is wrong because we need to stop the experiment after we get three consecutive heads. So this option is also ruled out. And similarly, this option is also ruled out because there are it do not have three consecutive heads and it stopped the experiment after three outcomes. Okay, so the correct answer will be second option. So I hope you understand what is the sample space here, like what is the meaning of sample space. Because these are very basic questions, but as we move on, these all things will be very important. So with time, you will see like how these things will become more complex. So if you have any doubt in the present questions, you can ask. Okay, so these are very basic questions as it's the first tutorial. So now moving to the next question. So you need to tell me like which of the is statement 1 is correct, or statement 2 is correct, or both the statements are correct, or both the statements are incorrect. Okay. So okay, we will see now. So probability of A union B is equals to probability of A is. So I hope you all are familiar with this formula. So now this is given as 3 by 4. Okay. So this is greater than 3 by 4. So this is also greater than 3 by 4, this whole term. So we can write that 3 by 4 plus probability of A intersection B is less than probability of A plus probability of B. Now we have given that this ranges within uh, it ranges within 1 by 8 to 3 by 8. So if we put 1 by 8, we will get so we will get 3 by 4 plus 1 by 8. PA plus PB. Okay, and if this is greater than this quantity, it will short that this will be greater than the quantity 3 by 4 plus 3 by 8, right? As 3 by 8 is greater than 1 by 8, so that's why like this will be the lower bound for this PA plus PB. So this will be 7 by 8, right? So PA plus PB is greater than 7 by 8. This is 7 by 8. And okay. Okay, and if we add this 3 by 4 plus 3 by 8, this will become 9 by 8. Okay, so PA plus PB will be less, not less than, but if, huh. Hmm. Okay, or you can write it as this way also. This P union PA union B will be PA plus PB minus 3 by 4. Oh. PA union B will be PA plus PB minus 3 by 4 and this ranges from 1 by 8 to 3 by 8. So 1 by 8 PA plus PB minus 3 by 4 and greater than, I think it is equal to what, or maybe just, I think it is less than or greater than. So now you can do this 1 by 8 plus 3 by 4 PA plus PB, and it is less than 3 by 8 plus 3 by 4. So this will be 7 by 8 PA plus PB, and it is less than 9 by 8, right? So now in the question it was asked that PA plus PB is greater than or equal to 7 by 8, which is correct, and PA plus PB is less than 11 by 8. So we have seen this is less than 9 by 8, so it will also be less than 11 by 8. So both the statements are correct. So anybody has any doubt in this question? So Saranya, are you trying to say anything? Ma'am, isn't that A union B? Uh, A union B is 3 by 4, right? So A union B is 3 by 4. It's in the formula element. No, it is like, so for this intersection also this will be this, like I just have written it differently. So this is PA union B is equals to PA plus PB minus PA intersection B. I just move this P intersection B here and P union B here. So I just interchange these places. Oh, okay, no problem. So because it's the A intersection B was given in a range, so that's why I wanted in left hand side. Okay, so now I will move to the next question. So this is the similar question as we discussed above, the second question we discussed. So try this one and then we will discuss. So we are given that the probability that Sita, Geeta and Ramesh will pass the test is 60%, 40% and 20% respectively. So what is the probability that Sita and Geeta will pass the test and Ramesh will not? So all these events that Sita will pass the test, Geeta will pass the test and Ramesh will pass the test, these all are independent of each other. So the the probability that we need to find is that probability that Sita will pass the test multiplied by probability that Geeta will pass the test multiplied by probability that Ramesh will not pass the test. So probability for passing the test is 60 for Geeta and 60 for Sita and 40% for Geeta, and probability that Ramesh will not pass the test will be 80% because passing test probability for Ramesh is 20%. So the multiplication of all these three units will be the answer. So so probability that Geeta will pass the test is 0.4. Probability that Sita will pass the test is 0.6. And probability that Ramesh will pass the test is 0.2. And probability that Ramesh will not pass the test, so that will be complementary of this event, that he will pass the test. So this will be 0.8. Now all these events are independent of each other. So the probability that Geeta will pass the test, union Sita will pass the test, and Ramesh will not pass the test will be 0.4 into 0.6 into 0.8, so which will be 0.192. Okay, so I hope so Sridev Basu gave the right answer. Okay, so can we move to the next question? So all people understand this, the solution for this question, right? Okay, so we will move to the next question. So please try to find solution for the eighth question, and I will discuss it in a minute. So in this question, this is not union, this is intersection. Not intersection, it is like and. Um, Union will be uh, that the probability that either Geeta will pass the test, Sita will pass the test, or Ramesh will not pass the test. But we want that these all the three events will occur simultaneously. So this will be more like and kind of thing. So it will be a kind of intersection. So it will be intersection, not union. And as these are independent events, this will be this. So formula for the independent event is Pg multiplied by Ps multiplied by Prc. Okay. So this is the probability that these all the events will occur simultaneously. Okay. If it is asked that either of these events will occur, then this will be union here, and then we will add the probabilities. We will not multiply the probabilities. We are multiplying the probabilities because it is saying that these events should occur simultaneously. So these all events, one thing I will clear you. So like, so there is, so let's say there are two events, event A and event B. Now we need to find that what is the probability that both the events will occur simultaneously. So if these events are independent, okay, if A and B are independent, this will be given by PA multiplied by PB. If A and B are dependent on each other, okay, dependent, like if occurrence of B will depend on occurrence of A, then this probability of A, like probability of this A intersection B, that these both events will fall simultaneously, will be this it's PB into probability of A given that event B has occurred. So this is the formula when it is given that this occurrence of A depends on occurrence of B. Okay. So I will explain it with an example. Mm, just a minute. So let's suppose um, if we uh, if we dice a roll, okay, if we dice a roll, if we roll a dice, sorry. So if we roll a dice, okay, and if the outcome is greater than 3, let's suppose, okay, if outcome is greater than 3, then we will going to toss a coin. Okay, and then outcome of it can be heads or tails. So now this is one event, this is another event, but this event, this tossing a coin, is depending on the this event, okay, of rolling a dice. If the outcome is greater than 3, then only we are going to toss a coin. Okay, so now if we want to find the probability that the probability that heads will occur after we are after that head will occur after we get a 4 on the first event, then the probability will be, the first probability will be like the probability of coming of 4, and then there will be this probability of heads given that this 4 has occurred. So probability of uh, of outcome of 4, like if we roll a dice, then what is the probability that 4 will occur? It will be 1 by 6. And so if this has occurred, then we will going to toss a coin, and the probability of coming ahead will be 1 by 2. So the answer will be 1 by 12. Okay, but if these both events are not dependent on each other, if we are anyway going to toss a coin, we are not saying that we are not keeping this condition. We will if we remove this condition, and this is independent of, these both events are independent of each other, then what is the probability that heads will occur simultaneously when we get a 4 on a dice? Then that will be, like in this case it is the same. um, so in this case it is coming out same. Mm. So please try this question. I will explain you this one. Like I will find a different example to solve. I think that one is not very good example. 9.47. It is 19. So we will see that there is a little trick in this question. I'll show you. So here it is given that the odds in favor of car P is 1:3. So probability associated with that will be 1/4. Okay. So I think you all got this, that this probability of that the car P will win will be 1/4. Okay, so this was the only trick. It will not be 1/3 because it is 1:3. So the probability will be 1/4. Similarly for Q, R and S, the probabilities will be for Q it will be 1/5, for R it will be 1/6, and S it will be 1/7, and the rest it will be same as we discussed earlier. So I hope you all understand this concept and you all have taken this thing in consideration. Okay. So it is similar to the question that is given above. So, so probability that 4 will win is 1/4. So the for 4 to win, like if only one of them is going to win, that means if P will win, then Q, R and S needs to lose the race. So the probability of that Q will lose is 4/5, R will lose will be sorry, will be 5/6, and same for S. So probability that P will win is 1/4 multiplied by 4/5, which is the probability that Q will lose, then 5/6, this is the probability that R will lose, and then 6/7, which is the probability that S will lose the race. Similarly, probability for Q to win the race is 3/4. This is the probability that P will lose the race. Then 1/5. This is the probability that Q will win the race. Then similarly, this will be 5/6. Probability associated with the event that R will lose. And similarly 6/7, which is the probability that S will lose the race. Similarly, we will find the probability that R will win the race and S will win the race. And then, so this will be again 3/4 multiplied by 4/5. And this will be 3/4. And then we will add all these quantities. Okay, because we want either of them will wins the race. So we want the union of all these events, right? We want union. That's why we will add the individual probabilities. So I hope you all can solve this problem. So now you just need to put the values in this, oh sorry, in this, like you need to solve all this expression. So who all got the same? Yes, Swapnil, why you are raising the hand? So the question which I was trying to explain, that the intersection kind, well, this that there, if there are two dependent events, then probability that this is the probability that event A and B will occur simultaneously. Okay. So this is the probability that event A and B will occur simultaneously. And if this is the formula when we know that event A is dependent on event B. Okay. So in the question, so this first question. So we have there that there are 6 good eggs and 2 rotten eggs, and if we are replacing them without if we are like removing the eggs without replacement, then what is the probability that both the rotten eggs are in the first two tests? So when we inspect one first egg, and the probability that it is rotten, this will be 2 by 8. Now the remaining rotten eggs will be 1 and total eggs will be 7. So the next probability of rotten egg will be 1 by 7. Okay, but this 1 by 7 is dependent on the previous event that the first rotten egg is removed, right? If the first rotten egg was not removed, okay, let's suppose uh, if we like grab a egg from that group and the first egg is good, and then we like we discarded that good egg from that group, then then the probability that the second egg will be rotten will be 2 by 7. So the second event is dependent on the first event. Okay, the probability of second event is dependent on the first event. So what I am saying is there are total 8 eggs, right? 8x, 6 are good, 2 are rotten. Now probability that if we if we take two eggs simultaneously, then one will be good and one will be rotten. So let's suppose that first should be good and second will be rotten. Then probability that the first is good is 6 by 8, and probability that second is rotten is 2 by 7, because because after first event we will remove the good egg. The total number of eggs will be 7, and among those 7 the rotten eggs will be 2. But if we finding this is intersection, but if we want the probability of the if we want the probability that in both the events we will get the rotten eggs, then the probability is first will be 2 by 8. Okay, because there are two total rotten eggs and 8 total eggs. Then if we remove one rotten egg, there will be only one rotten egg remaining, and there is total 7 eggs remaining. So this is the probability that in both the events we will get the rotten eggs. So here these events these events are dependent on the first event. Okay, so here this 2 by 7 is this probability of occurrence of event A given that event B has occurred. Okay, so do you guys have any doubt? Because okay, I will move to the next question now. So I just wanted to like clear this thing because this is a little confusing, and as we move forward this will become more complex in upcoming lectures. So I hope it is clear. So now try to solve this question. Tell you what's the question. Oh, this Bayes theorem, right. So I think you all are familiar with this Bayes theorem. Yes, Shridip, it is right. The answer is 0.045. So we have total tickets which are numbered from 1 to 20. Now we want that if we withdraw a ticket, then the number on that ticket will be multiple of either 3 or 5. So what are the numbers which are multiple of 3, first we will see for 3. So this will be 3, 6, 9, 12, 15 and 18. So the 21 will be then, like, because the ticket number is up to 20, so 21 we will not consider 21. So now we will see the multiple of 5. So it will be 5, 10, 15, 20. So we don't want to, this 15 is coming twice, so we will count it as one only. So there are total preferable outcomes are 1, 2, 3, 4, 5, 6, 7, 8 and 9. So total preferred outcome for our event will be 9, and total events, like the total number of tickets are 20. So this will be 9 by 20, which is 0.45. So everything is clear so far, right? So I am hoping that you guys have seen the lecture. Yeah, and if you have any doubt, you can ask in this session also. So that Bayes theorem thing is quite confusing for some people. It is confusing, like it is little confusing, and as we move forward, it will become complex. So that's why I just spent few time, like some time on that thing. Okay. So we move on to the next question. So try to solve this question. So we will see. There are total 2 red balls, 3 green, and 2 blue balls. And we are withdrawing 2 balls randomly and simultaneously. And we want that both of these balls should not be of blue color. So probability that first ball is not blue will be either that it will be red or green. So there are total 2 red balls and 3 green balls. So the favorable number of outcomes are 5, and total outcomes are 3 plus 2 plus 2 is 7. So this is the probability that the first ball which we drew is not blue. Now the second ball which we want to draw, and we want that that is also not blue. So now the total number of balls of red and green color remaining are 4, because in this thing we are extracting one ball from this two red and three green ball. So now total number of balls which are not blue are 4, and total number of balls remaining is 6. So this is the probability that the if we draw two balls simultaneously, then those two balls are not blue. Okay, so this is 10 by 21. So this is again the conditional probability that if we draw this first ball which is not blue, then the probability that the second ball is also not blue will be 4 by 6. Okay. So someone has unmuted their mic. Aren't we using combination? Oh, okay, combination. So, no, we are not using combination here. Like, I think you can use combination also, because that is also will be 5C7, I guess, right? A 5NC. 5NC. Mm. So, when you use combination, then so I think you are not getting the same answer as I am getting. It is not 10 by 21, right? Let me check this. That will be 7 factorial divided by 5 factorial into 2 factorial. So combination formula is used when we try to see like what are the number of uh, such combination possible, right? Mm. And this is probability, this is different. So for solving, can I find probability by getting two blue balls and subtracted from one? Oh. Huh, you can do that. So that will be 1 by 7 into 1 by 6. No, sorry, 2 by 7 into 1 by 6. I just tried this. Mhm. Everything. This is not coming the same. Then I think this the sum of all these events will be okay. Like will that be a correct approach? So I don't think it will be correct approach, because if you mm, so you are trying that you want to know that if we find the probability that the if we find simultaneously find uh, like picking two balls and those are of blue colors, then we so like this is here we are talking about two separate events that should occur simultaneously. We are finding the probability that these two events will occur simultaneously. So the state space for two events that are occurring simultaneously will be very high. And I don't think like we can like you can subtract it from one. Like if it's a probability that probability of picking one ball, like one event at a time, and if the probability that the ball is not blue, then you can do that the probability of picking the blue ball and then subtract it from one. But here we are talking about two simultaneous events. We are talking about P A intersection B, so I don't think it will work there, because you need to subtract not subtract. Just a minute. That this. Oh, so that will not be a correct approach, because here we are talking about two simultaneous event, and like this is the only reason. Because if there was only one event, then you can do this, and this combination part, it is not used for finding the probability. It is used for finding the number of those events, or how many number of such events are possible. This is not here we are finding the probability of that occurrence of that event, right? So I hope it is clear. So in this question, like this Sridip, as he asked, like uh, so he has a genuine doubt that for solving the above question, we can also approach it in a way that we will find the probability that the probability of getting two blue balls simultaneously and then subtract it from one. But this is not how the probability theory works, because here we are talking about two simultaneous events. That is why whenever there is a question, you need to follow the language. Okay, here the question it is asked that what is the probability that none of the ball drawn is blue. So we need to find the probability of that none of the ball is blue. We do not want to find the probability that any of the ball is blue. So try to follow the language of the question. So in the probability, it is very important to follow the language, because the calculation is not that tricky. Only the language and the way we approach is tricky. That's why this exercise questions are very much important in probability, and it is quite confusing, and I am also getting confused by the like small things, but yeah, it is confusing. So statistics is not that confusing part. This probability is more confusing thing, so we need to practice a lot in to become very good in probability. So now try to, so this is also like easy question. So please try to find the solution for this. So has everybody tried this question? Yeah, Avinash, that will come 20 by 21, which is not correct. The correct is 10 by 21. So that's why we cannot approach it in the way the Shridit was telling. If there was only one event, then we can approach this as uh, as that approach, that by finding the probability of occurrence of picking of a blue ball and then subtracting it from one. But here we are talking about two simultaneous events, then it won't work. So this is the question, like what is the probability of getting a sum of 9 from two throws of a dice? Okay, so if we throw a dice twice, so what is the probability that the numbers we get in both the instances, uh, the sum of those number will be 9? So we will see like what is, so a few people have given the answer and it is correct. So the possible outcome of rolling a dice will be 1, 2, 3, 4, 5 and 6. Okay, so now if we want the sum to be 9, then what will be the possible combination? It will be 3 plus 6, 4 plus 5, 5 plus 4 and 6 plus 3. So these so this is the, when we roll the first dice, when we roll the dice for the first time, this is the event when we roll the dice for the second time. That's why this event and this event are different, and this event and this event are different. So what this depicting is that when we rolled dice for first time, outcome is 4. This means when we roll dice for second time, outcome is 5. But however, in this event, this presents that when we rolled the dice for first time, outcome is 5, and when we rolled the dice for second time, outcome is 4. So these are two separate events. Okay, so that's why they are counted separately. So these are total 4 possible combination of events which will results in the sum of 9. So these are total number of such events are 4, and total possible combination of the numbers which will we get when we roll a dice twice, so that will be 36, like 6 into 6. So this one, so the possible outcome for, like let's suppose when we roll the dice for the first time, the outcome is 1. Now when we roll now the when we roll the second dice, then there can be 6 possible outcomes, and all those will be mapped with 1. So the possible combination will be 1 by 2, 1 by 3, 1 by 4. So similarly it will be for 2, 3, 4, 5 and 6. So there will be total 36 outcomes. So it will be 1 by 9. So I hope this is clear. Okay, so I have only this many questions to discuss today. So if you have any doubt, you can ask me now. So today we have discussed 11 problems. So if you guys have any doubt in this question in this session, you can ask me today or you can ask me on next Friday. And this video will be available. And to attend the other two sessions scheduled on Monday and Saturday. Are you gonna take higher level? So on Monday and Saturday, I'm not going to take the classes. Other TAs will take the classes. So, but this videos are available to you, so you can watch them whenever you are available. So we are going to record our sessions, and then we are going to upload this link of this session on NPTEL, or uh, you will get this videos. Yeah. So in all the sessions of Friday, I will try to solve few problems, and if you have any questions, then we can discuss those questions as well. So today this is my first lecture, so I am also a little nervous, and I'm also trying multiple things right now. So yeah, so with time I will also get better. And if there are any feedback from your side, then I will welcome those feedbacks. If you want to say like how I can improve, then you can say so. No, no, they will teach other set of questions. They will discuss something different. Okay, I will wait for next 5 minutes and then I will end the meeting. Yes, Avinash, there are various distribution. There is two type of distribution, discrete and continuous, so they will be discussed in the future sessions. Okay, guys. Thank you then. I will end the meeting now, and I will see you on next Friday.